Hi, everyone. Hi. Wow, they gave me the big room. This is awesome. I was expecting like a little intimate gathering, like I was like the little McLaughlin group, me and like 5 people talking about apps. But this is great. Thanks. I appreciate you guys coming. I know it is 5 o'clock on Wednesday. I'm standing between you and beer. I know. No illusions about that. So, yeah, the Intel thing is next. But it doesn't start till 6. So, I will get through this and we'll go have some beers together. So my name is Joe Marini. I am a developer relations advocate at Google, and I lead our DevRel team on Chrome apps, extensions, Chrome Web Store, essentially the Chrome platform, not the open web platform, the Chrome side of things. So what I'm going to be talking about today, by the way, this is all my contact info, so please feel free to reach out and say hi. Today, I'm going to be talking about how to build native-like experiences using HTML5. And before I get started, let me just quickly ask, how many people have heard of Chrome apps before today? Everybody. Oh, just everybody. That's great. OK. And how many people have gone to the Chrome Web Store to get stuff, extensions, whatever? Wow, everyone. All right. OK, you guys have a great night. I will. All right. No, I might as well talk. So before I go into the slides, I find it's usually pretty instructive to just give demos because I can explain what Chrome apps are and so on, but seeing them in action, I think, really explains a lot better. First, one of the things you notice right away about Chrome apps is that they look and behave just like native apps on the platform that they run on. So you see as I'm command tabbing through here, The Economist, and that one there, Glyphy, and that text editor. These are all Chrome apps. They're all built using HTML5. They behave like native apps. We haven't finalized the Mac experience just yet. That's coming, I think, in Chrome 31 maybe, but you launch them from the dock. You find them in Spotlight. You go to the Applications folder. On Windows, they're in the Start menu. On Chrome OS, they're in the Launcher. So they look and feel like real apps. So let me just pop over to The Economist really quick. Right away you can see there's no URL bar, there's no back/forward button, right? It's just a regular app experience. I can page through the content with my keyboard and get a nice, nice reading experience. You can see here it says available to read offline. That's because all the content's been cached offline. Let me jump over to Glyphy really quick. This is like a Visio type-ish app where I can do diagramming. I can just drag out shapes and connect things together. Again, though, it's like no URL bar. You can see up here in the Mac menu, there's an actual real menu up here. I have access to the native file system, so I can open up files. Right? Again, the point is, if I didn't tell you that this was HTML5, right, you probably wouldn't know. Well, I mean, you guys would probably know. My mom wouldn't know, though, right? The idea is that users wouldn't know. This is a Sublime-like text editor that one of our product managers built. Anyway, you get the idea, right? They look and behave just like regular native apps. And by the way, I know that there's mics and everything, but we're a small group, right? We're all friends here. So if you have questions, please feel free to ask. I want to keep this interactive. So if something isn't clear or whatever, if you're curious about something, just feel free to ask. All right, so now that I've shown you what Chrome apps are, the next logical question is, well, why would you do this? Right? Why build a Chrome app when we've got these great modern browsers, we've got HTML5, we've got JavaScript. Pretty soon, if you caught the previous session, we might even have parallel JavaScript. Well, web apps, as great as they are, and let's not make any mistake here. I mean, we're Google, right? We love web apps. Web apps are awesome. Web apps have a lot of great features, but there comes a time when web apps are not really quite that great, right? We've all seen this before. Making web apps work offline reliably is really hard to do. And it's not just because app cache is kind of flaky, although it is, right? It's not just technology reasons. There's also very real, human interface reasons. Most users just don't start their browsers up when they're offline because we've got, 2 decades of web experience now. Wow, am I that old? Yeah, so we've got 20 years of experience where users have learned, not online equals browser not work. So they don't even bother to start their browsers up when they're offline, even if the app does work with app cache, right? So offline is one problem. Let's see what else. So playing games on the web, right? It's great. You've got this nice big keyboard, hyper-accurate pointing device, right? Everyone loves playing games on the web. I love it. Problem is, there comes a time when games on the web just aren't that great, right? It'd be kind of nice if you could, use real controllers and have a really nice gaming experience on the web platform. And this is hard to do today, right? There's no, there's a gamepad API, not really widely implemented yet, but there's no way to like connect random USB devices to a open web platform app, or use Bluetooth, or use parts of the platform to get access, right, from a web app. So these are the kinds of problems that Chrome apps are attempting to solve. Right? Problem number one is offline. So Chrome apps are designed, just by their very nature, to run offline by default. All the assets are packaged locally. Right? The user clicks on an icon, they launch them like any other app, they start up, and they run offline. They also run across all the popular platforms. So because they're HTML5 and they run on top of Chrome, the runtime, right, you get Mac, Windows, Linux, Chrome OS just out of the box. And you'll also get iOS and Android via the Cordova project. Who knows what Cordova is? Just about everybody. I should just stop asking. Yeah, so via Cordova, we're actually one of the biggest contributors to Cordova. So we're taking the Chrome app APIs and building Cordova plugins with them, so you'll be able to build your apps that run on mobile as well as desktop. They're also designed to give you access to the native platform. Right? So things like USB, things like Bluetooth, raw UDP sockets, the kinds of things you want to be able to do on the native platform, Chrome apps are designed to give you safe access to those. And you saw before, they're also clearly designed to do things like an immersive user experience. Right? The user should feel like they're using an app. Right? It shouldn't feel like this ethereal thing. It's a real application. And your apps, Chrome apps, have control over their windows and the things that real native apps have control over. And you get all the distribution and auto-update goodness that just normally comes with the Chrome Web Store. So a user installs a Chrome app, you decide to make an update, right? You upload your update to the store. Every few hours, the Chrome runtime is pinging the store saying, hey, do you have any updates for me? Yes, I do. Down they come. So updates just get automatically propagated via the existing store infrastructure. So those are the problems that we're trying to solve. So as you go through this process, chances are, if you're not building an app from scratch, you're going to want to take an existing web application and move it to Chrome apps, right? That's a pretty common scenario. And most of you, I'm assuming, have experience building web apps anyway. So what I'll talk a little bit now is about some of the things to watch out for, some of the implications of taking existing web apps and moving them to the Chrome apps platform. So first, let me show you what Chrome app structure looks like. They're pretty much the same as any other web app, right? You've got your HTML code, you've got your JavaScript, your CSS, your assets, images, whatever, right? That pretty much just stays the same. So you build the content of the app the same way that you would build any other web app. All we do is we ask you to wrap some infrastructure around it, right? All you do is you define, for example, a manifest file. And the manifest file, its whole job in life is to simply describe to the Chrome runtime what the app's particulars are. Like what version it is, right? Its description, what permissions it has, what URLs it's allowed to access, that kind of thing. All that goes in the manifest file. And then you define a JavaScript file that handles all the runtime events. Things like being launched, being updated, some system alarm going off, a push notification coming in, right? That goes in the file that's labeled main.js. You can call it whatever you want. Main.js is kind of a thing that we just made up on the Chrome team because it's common, but you can call it whatever you want. And then the background HTML file, all that does is host the JavaScript file, main.js. And if you don't give us one, we'll just generate one for you. So you really only need to make 2 of these, not all 3. So the infrastructure is pretty simple, right? Just define a manifest. This is what my app does. Define the entry points into the app. And then pretty much everything else is HTML5. And that's generally our philosophy, is to use HTML5 wherever possible. And if HTML5 does not provide a certain capability, then that's where we look at providing an API for you. Yep, question.
For the main.js,
yeah.
Is that something you provide, or is that, or at least provide a model of, or is that something you're asking developers
Yeah, so is main.js something that we provide a model of, or do you guys have to build it, basically? Yeah, so you build the main.js file because that's where you define your event handlers for like, okay, when my app gets launched, I make this window, right? When a context menu gets selected, I do this action. So we have a whole bunch of samples on our GitHub that shows how to do it, but it's a JavaScript file that you make for your app, just like any other JavaScript file that you make for your app. All right, so let's talk a little bit about some of the principles that I outlined earlier. So like I said, Chrome apps are designed to work offline by default. What that basically means is that your app can be launched at any time, whether you're online or offline. And in fact, the first time I run it might be offline, right? So this has some implications. So first, you've got to determine what your disconnected experience is going to be, including the first time I run it. If I decide to run the Economist app for the first time offline, I went to the Chrome Web Store and, oh no, I'm late for my flight. I jump on the plane and GoGo is its usual self, not working, right? I have to have some experience. You don't want the user to come up with some white screen that says, 500, whatever, right? You have to have some content there. So that's something you need to think about. The other thing you need to think about is that resources, except for audio and video, need to be local to the app. One of the things that you can't do in Chrome apps is an image tag, source equals path to some random image on internet, right? Those assets have to be local in the application. And in fact, that's a pretty common scenario. So we actually made a asset loader library that uses XHR to go and get things like images, bring them down for you, and then put them into your app. And that's in our GitHub repo. I'll show that in a little bit. So figuring out what your features are going to be when you're disconnected, handling situations like when data is stale or needs to be synchronized. We provide a synchronization framework for Chrome apps, and you have some control over how you want sync to handle things like conflicts, and I'll talk about that a little bit later. Some of the web standard stuff are things that we don't support out of the box in Chrome apps, and window.local storage is one of them. Does anybody know why? Anyone want to guess? Size, yeah, kind of. It's actually, the real reason is because it's synchronous. And so what happens is we can't have the user just sitting there while you're trying to store 5 megabytes of data or get it, right? So in places like this where APIs are synchronous, we give you asynchronous versions of those APIs, right? Same thing, it's just Chrome storage instead of window local storage, but the API is essentially the same. So what this means is you have to plan for having a great offline experience. So factor the app, right, to store resources locally. If your app consists of a lot of PHP script generating HTML on the fly, that's going to be a little bit of a refactoring job, right? You need to figure out what your app's offline features are going to be. And not every app has to work perfectly well offline. That's not what I'm trying to say here. What I'm trying to say is the user experience just shouldn't suck, right? I mean, so think about Skype, for example, right? Like Skype, 95% of Skype is only valuable when you're online. Right? But when I'm offline, I should be able to manage my contact lists and see my call history and so on, right? So, but I should be able to have some value, right, when the app is not connected. You can use standard HTML5 events like the online, offline properties and the respective events to see when you're going on and offline. So update your UI appropriately. You can store data. There's various things you can use to store data. We give you a storage API. You can use IndexedDB. You have full access to the file system. We even provide a sync file system, which I'll get to in a little bit. So lots of stuff you can use there. One of the things we also, yeah.
So one thing related to the last one.
Yeah.
Do you have a file size limitation for an app?
Is there a file size limitation for an app? No. If you want to use the HTML5 file system, it's a real file system, by the way. You can write to the disk. Then the limitation is whatever the disk size is. So so Chrome apps, they come with their own sandbox, right, which is a local sandbox file system for your app, and nobody else can see it. So you get to request a quota, right, and you can say, by the way, I want unlimited storage space for my app, right, but you can also write to the open file system via user interaction with dialogues and such. So, but basically it's disk space. So to give you an example, this is the Chrome storage API. So let's suppose I had a form, right, and I want to save the value of a text field. Normally I would use window local storage for that, but here I don't have that. So I have my local storage, and I call set. I give it an object with values, and because it's asynchronous, I have a callback function, right? And the callback function just gets invoked when the operation completes. And if you care, that's great. If not, you just go on your merry way, right? So just asynchronous versions of it. So in addition to offline by default, right, we also want your apps to be what we call cloud-enabled by default. We have a lot of great cloud services, both at Google and elsewhere, other third parties, and we want to make it easy for your apps to be connected to the cloud in addition to working well when they're individually isolated and offline. And clearly, users expect this, right? We live in an increasingly cloud and connected world. Users expect that their data is going to be synchronized, so there's some implications here. So I talked a little bit about synchronization a little bit earlier and things like conflicts. But remember, your app might be used across multiple OSs and form factors. So you can specify how you want things like sync conflicts to be resolved. The nice thing is we actually give you some really cool cloud features. In addition to Chrome Storage Local, which I showed a few minutes ago, we give you a sync version of that. So have you guys noticed how when you use Chrome on different computers, your things like your bookmarks all sync between the different versions? We actually give that infrastructure to you. So just by using Chrome Storage Sync, you can sync settings across multiple instances of your app. It's 3 lines of JavaScript, and your apps keep all their settings and properties in sync, just like Chrome does. We also give you a sync file system. So the Chrome Storage Sync is for relatively small bits of data, right? Preferences, that kind of stuff. But the sync file system API is a space on the file system where if you write data files, we'll sync that across instances of your app using, in this case, Drive as the back end, but it's extensible. So, if Dropbox, for example, wanted to plug into this, they could. So it's open, but out of the box, it comes with Drive syncing. Now, the folder on Drive, we actually hide it. We don't show the user that synchronization folder. So you can sync your files in there, but we want to be somewhat transparent. So if the user knows how to look for certain file names, they can be able to find the files, and then they'll see the folder. It's basically the ID of your app. But by default, we don't show that in the UI in Drive. Another nice feature of the cloud features in Chrome apps is that we give you a push messaging API, right? One of the things you can't do in an open web app is have a web app respond to push notifications when it's not running, right? If the user doesn't have your app up in the browser, then your app's just not running. But in Chrome apps, we've taken Chrome, the browser, and we factored out the browser from the underlying runtime. So even if your app is not currently running, the underlying runtime is. So your servers can send a push notification through our back-end Google Chrome messaging infrastructure. That will then get sent out to the runtime on the user's machine, and then your app can actually wake up in response to that message and do something, which is actually kind of nice. How many people love writing OAuth code? Love it. Yeah, me neither. Yeah. So one of the things we set out to make really simple was identifying, giving identity features to your apps. So we built an identity API that makes this pretty simple. And I'll show an example in a little bit, but what's cool is that there's basically 2 versions. One is for Google properties. So if the user is signed into G+ or whatever else, Gmail, you can just simply ask for their identity and you'll get it. And there's a third-party version as well. So if you want to authenticate via Twitter or something else, that's also pretty easy. So let me give you an example of what some of the code looks like. How am I doing on time? I'm doing all right. So this is an example of synchronization conflict handling. Can you guys, the code's a little bit small. I tried to make it big enough to read, but essentially what this is doing is, the first line here is telling the sync file system API to set the conflict resolution policy to the last write winning. Now you can say, I want the last write to win, or you can say, I want it to be manual, in which case you can deal with conflicts however you see fit, but it's up to you. And then to use the file system, it's really simple. On the file system API, you simply call request file system, and this is an HTML5 standard. So you get an HTML5 file system back on this. Again, it's asynchronous. So once you've got the file system, you can go off and create directories and files and do whatever else, as long as your app has permission to do so. You have to request this. It's not by default. In the case of identity, there's the identity API right here. The first line, get auth token, that's the Google properties case. So basically you say, get the auth token, and if the user's logged in, then you'll just get their authorization token, and then you can go off and access Google properties and services. If you want to use the launch web auth flow version, that's for third-party services. And essentially the way that this works is, normally in OAuth flow, what you do is you pass a redirect URL, right, to the service. So the user logs, so you call the third-party app, the user logs in, right, then the third-party app redirects to this URL, and it's this wonderful, like, complex dance that goes on. So we've simplified that, so all you need to do is specify a callback function, and when the user logs in, that callback will get invoked with the token. So you just simply grab the token, and then you're authorized and you're off and running. You don't have to deal with any of the OAuth stuff directly. All right, let's talk a little bit about user experience. So I showed this earlier, right? Chrome apps live outside the browser. They can have rich UIs, right? But what that means is that in this new world where you're building apps and not pages, your apps are responsible for things that they were not responsible for in the past, right? And I'll give some examples, but users essentially, they have different expectations of how apps are going to work versus a website. So we give you a windowing API to manage your app's windows. You can create windows, it's up to you. You can do things like determine what the screen size is, to figure out where you want to put the window and how you want it to be sized. You can remember what the window's location and size were between invocations of your app, because I don't know about you, but nothing annoys me more than an app where I get the window set right where I want it and placed right where I want it, and then I quit the app and I go back and it's this big again, right? Well, that's an example of things in the past where your web app didn't have to worry about that stuff because the browser said, well, here's your window size. And your app was like, okay, I guess that's my window size. Well, in the world of apps, right, you control all of that. You get to decide how big your window is. You can also control the appearance. So if you don't like the fact that your app's windows look a certain way on a certain OS with the native title bar and the native window controls, you can turn that off. And you can build your own title bar, and you can build your own minimize and maximize buttons. All you need to do, basically, is use a WebKit property called WebKit App Region. You set that to be the drag value on whatever you want to be the drag region, and that's your title bar for dragging around. And then we give you APIs for things like maximizing, minimizing the window, listening for when that happens, that kind of stuff. In addition to that, we give you an API for handling context menus. Users have this annoying habit, right? They right-click and they want something to happen. So we actually give you a native context menu API for handling things like right-clicks, and it actually uses the system native context menu. What's cool is that it works outside your app. So you can define a context menu that when the user right-clicks on your app's icon in the launcher, for example, you can define items that go in there and then listen for events when they click on things outside your app. So it's actually like another way of integrating with the host OS. We give you an alarms API, so you can set alarms for periodic events. And again, those work when your app's not running. So you can say, hey, wake my app up in the future in an hour, right? Set a reminder or whatever. We have a media galleries API to make it easy to access things like photos and videos on the user's computer. So each various OS out there has its place where it keeps its media, right? Pictures, movies, whatever. So a simple API for getting access to that. And again, all the stuff I'm talking about is all behind various permissions. So when the user installs the app, they get told, by the way, this app wants to work with media or whatever else. But assuming that they say yes, your app has access to this kind of stuff. All right, let's talk a little bit about the platform. So I kind of alluded to this a little bit earlier. Chrome apps can access the native platform, so things like files, which I already talked a little bit about. But you also have access to the USB ports and the Bluetooth on the machine and raw sockets and stuff that regular open web apps have not had access to before. And as you might imagine, there are some implications here, right? Of course, privacy and security are pretty big here. Right? Once you start accessing things like Bluetooth and the network, right, privacy comes into play pretty quickly. So you should be clear with the user when you're using resources like this, right? In some cases, you don't have a choice. In some cases, you get access to the camera, the little light comes on, right? That's just a user security thing. But just in general, it's a good idea to let the user know that, hey, you're using some shared resource. And then, of course, make sure that you let go of it when you're done with it, because other people might want to use it as well. But Chrome apps have access to this stuff. All right, so that brings me to security. How many people have heard of content security policy? Not that many people. I put a link in the deck. And by the way, these slides will be available online. I don't think I mentioned that up front, but they will be. So content security policy is essentially a way of defining what apps are and are not allowed to do. Sort of like it's, in the open web app world, it's kind of like cross-origin resource sharing, right? Whether or not you're allowed to get resources from different websites. CSP takes that a step further. CSP basically says, hey, where can content come from? Where can scripts run? But it also imposes constraints on how you actually build the app as well. So first, we don't allow things like the use of eval. We don't allow the use of things like new function in Chrome apps, because these are notorious sources of security issues and various bugs, so we turn these things off by default. All your JavaScript code has to be in separate JS files. You can't have inline JavaScript inside the web page in a script tag in the head, like you would in a web page, right? The reason is because we have no idea how that script got there, right? If somebody somehow gets control of that web page and starts putting script tags in, right, that code just runs in the context of your app, and so we disallow that. Your script's got to be external. You can't do things like inline event handlers. You can't say body, onload attribute equals some name of some function. You've got to use the add event listener DOM way of doing it. Again, it's, these are all like security and various issues. If you use iframes, and iframes are allowed, you can use iframes in your Chrome apps, but they're sandboxed into their own origin. So that way the content in the iframe can't poke up out of the iframe and get access to the contents of the page, and vice versa. The Chrome app can't load some random site and then start messing around with its contents either. They can communicate, so post message does work, right? So you can do that, but you can't do things like crawl Chrome apps, Chrome APIs from inside an iframe, right? It's just a security thing. And I think I talked about this a little bit earlier. You've got to declare where your content comes from if it's not local. So like I said earlier, audio and video can be remote, but your Chrome app has to specify in its manifest, by the way, I get content from here, right? These are the URLs where I get content from. And so that's got to be specified up front. So just to take an example, right? This is inline script and a head tag with an onload handler. That's not good. You got to use add event listener, and you've got to use no attributes. But then the question usually comes up, but what if I really want to do that stuff? Somebody ask. Yes, thank you. What if I really want to do that stuff? All right. So you can actually do that stuff. We do give you a way of accessing web features that CSP would ordinarily have blocked. So for example, if you want to embed web content in your app, this is a pretty common scenario, right? You've got rich help content or whatever. You want to show a window that has browser content in it. We provide a dedicated web view control for showing web content inside your app. It's basically embedding Chrome inside of Chrome. And it gets kind of inception very quickly, but it's really cool. So you can, and again, post message works, so you can communicate between the two. You can also execute script in the context of the web view, which is really nice. So for accessing remote resources, we provide a framework for this. You can use XHR to go get resources from the internet, put them locally in your app's sandbox, and then refer to them using blob or object URLs. And I said earlier, this is a pretty common scenario, so we have a JavaScript library that's open source to do this. It's on our GitHub. So a common problem occurs when you want to use things like templating libraries, right? Because templating libraries do things like eval and new function all the time. So there's a couple of options you have here. Number one, you can use a library such as Handlebars, for example, that lets you precompile your templates, right? That gets you out of the situation of having to use eval or a new function. But you can also tell the Chrome app runtime that you want a specific page to be sandboxed within the app. And then that page is treated as a potentially hostile page where it can run whatever code it wants. It can do eval, it can do new function, but that sandbox page of your app loses access to all of the Chrome APIs that the rest of the app has access to. So you can still do the post message trick, right? But you can't just simply call Chrome APIs directly from a sandbox page. So that's another way to get around that. All right, so let me just give a quick summary, then we'll talk about I'll show you guys some code examples. So I talked a little bit about offline, right? Making your apps work offline requires thinking about what kinds of features you want to make available, how you want the app to work, what's the first run experience, making sure that all your assets and code are stored and run locally. For the cloud, right, we give you access to the Google syncing architecture, various features for making cloud work, like identity and the sync file system. For the user experience, remember, your app is now an app. It's not just a browser web page anymore. You get to control things like what you want the title bar to look like, how many windows you want, where they go. So it's a real app now. We give you access to the platform, right? APIs for USB, for Bluetooth, for sockets, things that make your app look and feel like something a native app developer built. Security is probably the place where a lot of people trip up first. There's actually a really great article. I'll show it in the browser in just a second, and all these resources will be available in the deck after the conference is over, so don't worry about it. You don't have to like write everything down really quick. But yeah, so security, content security policy, if you haven't read about it, you should probably take a good look. There's a really great primer online that explains what CSP is and how it works. It's implemented both in Chrome apps and extensions, so it's good to get familiar with it. But then just some basic stuff, right? Stuff that you should probably be doing anyway, like separating JavaScript from HTML, right? Not using inline event handlers. A lot of that's just good style practice anyway, and CSP enforces it. And then using things like sandbox pages to execute code that otherwise wouldn't be safe in order to accommodate things like templating libraries and so on. So let me just show you guys some real-time examples. First, here's that story about CSP. This is an introduction to content security policy. This is the link that slide leads to. So if you click that link, this is where you'll go. It's a pretty quick read, and it explains what is ordinarily a pretty complex topic pretty simply. So this is the homepage for Chrome apps. It's basically developer.chrome.com/apps. This is our mission control for all the things to do with apps. So if you come here, this is what you'll see. Quickly, I just want to scroll down, though, to the Chrome Platform API section. So these are all the various APIs that we provide to your Chrome apps in addition to whatever HTML5 does. And again, to be clear, these are not available in Chrome, the browser, right? They're only available in the apps runtime, and some of them are available to extensions too. Some of them are shared with extensions. But obviously, we don't want to fork the open web, so we're not going to put these in the browser. But whenever we do make one of these APIs, we do it with an eye towards eventual potential standardization, right? Everything that we do here is all in the Chromium open source tree, so we commit all that stuff back to the open source project, and at some point, maybe this stuff will be standardized. We've actually already started talking with Mozilla about some of this stuff. So the manifest file, for example, they're doing something pretty similar with like Firefox OS and Firefox apps. And there's no reason why our manifest file needs to be proprietary or different from theirs. So we're already having some early discussions about how we might potentially standardize some of these things. But anyway, this is where you'll find all the APIs. And there's quite a few of them. This list used to be quite a bit shorter, and it's gotten pretty good. If you're interested in looking at the samples and trying some of this stuff out, we have a GitHub repo. It's basically Google Chrome/Chrome App Samples. Again, we accept pull requests, we accept contributions, as long as they're good, of course. But this is a place where you can pretty much find samples that exercise every one of the APIs that I've talked about. If there's an API, there's a sample for it, usually more than one. And you can see as I scroll down here, there's a bunch of samples in here. And if you haven't had a chance to go to the Chrome Web Store, we recently shipped support for Chrome apps in Windows and Chrome OS. And Mac and Linux support is coming pretty soon. I think it's either targeted for 31 or 32 of Chrome, which is within the next several weeks. So, but these are available in the Chrome Web Store today if you're a Windows or Chrome OS user. If you're on the Canary version of Mac Chrome, you can also find them as well. So if you're running the latest Canary, they're there. All right, so let me just jump over to some code really quick and show you guys some examples. Is that font size big enough? Yeah? Okay, cool. All right. So this is the hello world example. So if you go to the GitHub repo, this is what you'll find in the hello world folder. Essentially, you can see it's a pretty straightforward HTML file. It doesn't really do much. This is the main.js file right here. You can see what it's doing is it's asking for whatever the screen's available width and available height is. And then I give my window a default width and default height. And then I'm listening for the onLaunched event. Right? So when the user launches this app, that event will get triggered, and that's what runs all this code. And then I just have a Chrome API that says, hey, create a window. Right? There's the index.html for that window. I give it an ID, and then there's a bunch of properties that I can say, here's how big you are. And I can also do things like just determine whether the windows are sizable or not, or what the minimum maximum size can possibly be. So you have full control over this stuff. And then this is the JSON, this is the manifest file, which you can see just a bunch of JSON properties. Again, this particular example, not particularly complex because it's just a hello world app, doesn't really do much. So let me jump over to my browser. Here it is. And what I'm going to do is launch our handy dandy apps developer tool. And I'm going to make sure that, yeah, okay, it doesn't look like it's currently installed. That's great. So all I need to do then is click on Load Unpacked. And then in my documents, I've got my Chrome app samples. And I'll scroll down to Hello World. And I'll select that. And you can see that it's loaded. And I can just go ahead and launch it from here. And you can see I'm up and running, right? Now, what's cool about this is because this is Chrome, right? It's the runtime, it's not the browser, but because this is Chrome, you get access to all the great developer tools that you're already used to using inside Chrome. How many people use the Chrome dev tools? Almost everybody, great. So let me just right-click on this, and you can see that I can do things like reload the app, simulate the restart. I can also inspect both the current app page as well as the background page, which is that main.js file, right? So I can set breakpoints in my infrastructure file. So if I say inspect element, right, you can see the Chrome DevTools. Let me just zoom this up so you can see what's going on. So this is the Chrome DevTools, right? So you have access to all the same DevTools that you're used to using when you're building your web apps, which is actually a really nice experience. All right, let's look at something a little bit more complex. Let me close this. Let me go back to Sublime, and we'll close this one. So this is an identity sample. So this sample uses the identity API. So again, I have a pretty straightforward HTML page. I've got an empty div right here where my identity information will be displayed. And I have a sign in button and a revoke button. All right, here's my main.js, right? So again, all I'm doing is just creating a window. In the manifest file, what I'm doing here is asking for the identity permission. So my app says, hey, one of the things I want to do is access the user's identity. And if I don't have this, then I can't use the identity API. So I have to specify this. And then all I need to do is specify whatever my app's client ID is, which if you've ever built a cloud-based app using the Google console, it's the same ID that you get from there. And then I just simply say what OAuth scopes I want this app to have. So in this case, I want it to have access to my G+ login information, right? So pretty straightforward. Let me go back to the apps tool. All right. I will load this one back up to the folder. There's identity right there. I will select that. All right, so that loads. And I will launch it. All right. And you can see I'm already signed in, so there's my name and there's my smiling mug, right? So now if I revoke this token, and if I click sign in again, right? So I get my little, hey, this app wants to do mean things to you, is that okay? I say yes, right? And there's my information, right? So again, making things like Cloud API and identity access pretty simple. So that's pretty much all I have. I really appreciate you guys coming. If you have any questions, yeah, sure.
So at no point, if the app requests the credentials,
Yep.
you click the signing button,
Right.
it automatically assumes, how did it know?
So in the case of this example, I'm signed into Chrome as me as my identity. So I'm getting my Google identity. So since I've already done that in the browser, it just says, oh, the user's already signed in. I don't have to ask for email and password. If I had signed in through a third-party service like Twitter, it would have said, here's your username, here's your password. Or if I wasn't signed into G+ right now through the browser, it would have done the same thing. Yeah, sure. Yes, exactly. Right, exactly. By the way, thank you, guys. I appreciate it. Thank you so much. Yeah. All right. Yeah. Support. So for Android, we are currently for both. The plan is to use the PhoneGap/Cordova framework. So when Adobe bought PhoneGap, they open sourced a bunch of it, made it Cordova. So we have a team in Waterloo that's right now dedicated towards porting a lot of these APIs over to Cordova. And there's a GitHub repo for that as well. If you go to GitHub, it's called Mobile Chrome Apps. Right now, we've only got about maybe 5 or 6 of the APIs ported. So identity, storage, alarms, I think, right? But the plan is that we're building plugins to Cordova. And so that's the current plan to get to iOS and Android. Now, hopefully in the future, we own Android, right? So we're thinking about ways that we might just get these to work on Android at some point in the future. I mean, no current things to announce around that, but we're thinking about it, right? It doesn't solve the iOS problem, obviously, because Apple will never permit that to happen, let's just be honest, right? So PhoneGap and whatever, and if we add other platforms in the future, like, I don't know, whatever other phones, or let's say BlackBerry comes roaring back, right? So we'll need PhoneGap for that as well. But that's the current mobile plan is Cordova, and then hopefully other things in the future. Yeah. So the question is, you're using third-party frameworks like Angular and jQuery. Yeah, so we've actually tested Chrome apps with a bunch of those. So jQuery works, right? Angular later than 1.10 works out of the box. Prior to 1.10, you have to put a little ng-CSP attribute on the HTML tag, and that tells Angular, by the way, this is a CSP situation. But that'll be resolved as 1.10 gets released. Yeah, we've tested it with a bunch of frameworks. Bootstrap, for example, just works, right? The only place where you get into trouble is where things like the code is mixed in with, HTML and whatever else. And again, the way around that is just put it into a sandbox page so that it works, and then you can just like do some post messaging back and forth. But most of the popular libraries that we've tested seem to work out of the box. So, yeah. Can you communicate with native apps? Yeah, actually you can. There's an API for doing native messaging. So you have a native app on the machine. There's a way to send. Looks like she's sending me messages. Sorry about that. So there's a way to send messages to native apps on the computer. So your app has to be expecting it, right? You can't just send random messages to native apps, but there is a way to do that. Yeah. Other questions? Yeah. Yeah, sure. I'll repeat.
What about distribution? Do you always have to go through the Google Chrome store?
So the question is distribution. Do you have to use the Chrome Web Store? So we require that Chrome apps be hosted on the Chrome Web Store, right? So you can distribute the app through your own website. We have a feature called inline installation. So you provide a link to the app in the store, and when you add the app, the user will get the same experience. The little dialog will come up and say, hey, do you want to add this, right? And you can also do things like, if you don't want the whole world to see your app, you can hide it so that only people with the link can see it. So yeah, but we require that the apps be hosted in the Chrome Web Store because our backend does things like scan for bad malicious actors and things like that. So yeah, it's same with extensions right now. Yeah.
Yeah, I wanted to know what's the support for web components?
Sure. Yeah. So yeah, so the question is, what about things like custom web components, for example? And so yeah, there's a project going on right now called Polymer. Yeah, so it's still very early days, but the polyfills work, right? And so the plan is to officially support web components as they get built, right? So the Chrome team is busy implementing the spec as it becomes more and more stable, and because we refresh Chrome every 6 weeks. As it gets more and more solid, it'll just work. So yeah, the plan is to just support native web components as they become ready. Well, I mean, if you want to do it today, no, it should work. You'll just have to use the polyfills, right? You just can't. I mean, it's not. I mean, I don't know. I haven't checked recently to see what the current state of the native stuff is. I think it's still pretty alpha, right? It's not, but it should work. Whatever the Chrome browser currently supports, the runtime should just give you. So.
Are they, so I think you just answered this, but are they refresh, is the Chrome app runtime refreshed at the same rate as the
Yes, it's refreshed at the same rate as Chrome, yeah. So basically like I said, so the way we get the runtime out there is, it's basically Chrome, right? So you have to have Chrome on the system in order to run these apps. It doesn't have to be the default browser, right? It can be whatever you want. But Chrome the current state of the world is, and this is version 1, let's remember, the current state of the world is that Chrome has to be on the machine. And in the future, we'll look at scenarios where we install the runtime if it's not there. And it can also be Canary, but the Chrome Web Store won't distribute Canary. It'll distribute whatever the current stable is, yeah. Right. Future APIs, yeah. I mean, the list has gotten pretty long. I'm actually excited. There's a couple of good ones. One of the ones I'm personally excited about is that we're about to add an API that lets Chrome apps register as URL handlers. So, like, for example, your Chrome app can say, I'm responsible for this URL, as long as you own the URL. You can't say, I'm responsible for Gmail, right? But you can say things like, my app handles whatever, it's to my domain, and I can prove ownership of the domain via the Google Web Tools, the Webmaster Tools. Then you can register as a handler. So that's a pretty cool one that's coming up. We're giving, we have APIs for writing to the media galleries as well as reading, which will be pretty neat. So yeah, I mean, as needs come up, we address them. So yeah. Yeah. Well, the app is just an app, right? Yeah. So the app is not part of your website, right? But if you want to do things like access your domain, or in certain cases, like to go into the Chrome Web Store, if you want to distribute it through your domain, you've got to prove that you own it, right? If you want to access the content on your domain, you have to have the scope authorization to do that. So, but there's a couple of ways. So Google the Webmaster Tools gives you a bunch of different ways to prove ownership, right? You can do things like put a magical file on the root of your web server, which the tools then go find. You can put a meta tag in there that has a key in it. There's a bunch of different ways to do that. So. Yeah, sure. All right, if you have any other questions, I'll be around. I'll probably be having beers with Intel, so come stop by and say hi. But thanks, guys. I appreciate it.